Basic proportionality theorem. It says that if a line is drawn parallel to one side of a triangle intersecting the other two sides in distinct points, then the other two sides are divided in the same ratio. This means if there is a line, if in a triangle ABC there is a line PQ which is parallel to BC, then this line divides the other two sides in the same ratio, in the same proportion. That means that this ratio, AP ratio PB, is equal to this ratio, AQ ratio QC. So, what we have here as given is in triangle ABC, the line PQ is parallel BC. And we have to prove that AP upon PB is equal to AQ over QC. AQ over QC. So let us see how can we do that. So students, for this we have to do some construction. What kind of construction? We will have to join BQ and PC. So join BQ and PC. One more thing we have to do is that draw a perpendicular from P on AC. From P we are drawing a perpendicular on AC. This perpendicular's foot will be M. So draw PM perpendicular AC. One more perpendicular we have to draw from Q on AB. So we are dropping one another perpendicular on AB. PQN, QN and QN perpendicular on AB. Now let us move for the proof. But before we move from the proof, we have to understand the areas of a triangle. See, you know very well, in this triangle, the area of this triangle, if we take this side as base and this is the altitude, then the area of this triangle is clearly 1 by 2 BH, half into base into altitude. Now here in this triangle, here is a problem. If we are taking this side as the base, then the altitude has to be dropped from this point. When we are dropping the altitude, where will be its foot? To find its foots, we have to extend this side of the triangle this way. Then this will be the foot of the altitude. Suppose this altitude is H dash. Then the area of this triangle will be 1 by 2 into B dash into H dash. So here in this case, the altitude goes outside the triangle. It is exterior. So we can see this. We can apply this there. Here, now come back to the proof. Here we shall take two triangles. One triangle we have to take is APQ, this whole triangle. APQ, this whole triangle. We will take it down, area of triangle APQ as numerator, and as denominator we have to take the area of this triangle. Area of BPQ. So of course in both the cases half into base into altitude will be there. Half into base into altitude will be there. Now for this triangle, this whole triangle, let us take AP as the base. AP as the base. Then altitude is QN. So let us write down QN. Now for this triangle which we have shaded, let us try to take the base on this side only, on AB only. So hence we have to take the side BP as the base. BP. Now students, you try to tell what will be the altitude for this triangle when BP has been taken as base. So see, here is a triangle, BP is the base, so altitude has to be dropped from Q. Hence the altitude comes like this, QN. So altitude for this triangle will be QN. Let us write it down there, QN. Now you see, half is gone by half, QN is gone by QN, and we are left with AB over BP. Let us name this equation as equation number 1. Clear students? Now we are going to the other side. Here again we shall take the same triangle as the numerator. Which triangle? This whole triangle. We shall take this as numerator ABQ. But at the bottom we shall take the other one. Which is the other one? I'll try to shade this differently. This triangle we are going to take. Now we shall take this triangle PQC. This triangle. Area of triangle PQC. Students, this time for the triangle on numerator, we shall try to take the AQ as base, because now we have to go to the other side. So half into base AQ. So you try to tell me now, if AQ is the base, so here we have taken AQ as the base. AQ as the base. So of course the altitude is PM. PM. Now in the bottom, for this triangle, half into base. Now you must have understood, earlier we took the base as AQ, now we have to take the base as QC. QC. Now if we are taking base as QC, for this triangle, QC we have taken as base. So altitude is clearly PM. This is the altitude, isn't it? If we have taken Q as base, the altitude will drop from P. So PM is the altitude. PM is the altitude. So now you can see half is gone by half, PM is gone by PM. So now we have got AQ upon QC. Let us name this equation as equation number 2, or this result as result number 2. Now students, we shall take a break to understand another concept which we are going to apply here. What is that concept? Suppose there are two parallel lines. 1, 2. Suppose these are two parallel lines, and now there is a line segment on this. So line L, this is line M. There is a line segment on this. You can see LM, and the distance between two lines, these two lines, is H. Now with the same base LM, so this is H. What does this mean? This means that here the distance is same 5.2. Here also the distance is same 5.2. Here also the distance is same 5.2. Right? So that means the distances between these two lines everywhere is same. Let us name this as H. Now, wherever we draw the distance between these two will always come to be H. This is also H. This is also H. This is also H. Now I am going to make 3 triangles or 2 triangles with the base LM. Let us one of them be PLM. PLM. What will be the area of this triangle if we are taking LM as base? It will be half into LM into this altitude PQ. So you can see PQ is equal to H, isn't it? PQ is equal to H. So this is half into LM into H. Now I'm going to make another triangle with the same base LM here and here. Let's take this as ALM. So what will be the area of ALM? Half into LM into this altitude. This again is H, isn't it? This distance is H. So this is let us say AB. So the area of this triangle is also half into LM into H. So we can take n number of triangles with the same base between same parallel lines. Areas will always be same. So what is the rule we are taking? What is the rule we have learned? The rule is there, the area of 2 triangles with the same base and between same parallel lines is always same. The 2 areas are always same. Let us take down this as a line for our theorem like this. Since areas of 2 triangles between same parallel lines right and same base, correct? I repeat, this is important. Now like we had drawn these 2 triangles with the same base and they were between same parallel lines. One line was this, one line was this. They were parallel. Then the area of both of them came out to be equal. Are equal. Areas of these 2 triangles are equal. That means now here the area of these 2 triangles is also equal for the same reason. See, this is the yellow triangle on PQ. This is the brown triangle. This again is on PQ. Base is same. Now these 2 are made between same parallel lines. These 2 triangles are again between same parallel lines, PQ and BC. Right? So here also, that is why the area of these 2 triangles will also be equal. Therefore, area of this triangle, which one? BPQ, yellow, BPQ is equal to area of the other triangle, brown one, its name is PQC. Right? Now try to connect this with this. Here BPQ is in the denominator and PQ is also in the denominator. And what is in the numerator? Triangle APQ, triangle APQ. So let us divide both of them by the area of a triangle APQ. We are dividing BPQ and area of triangle PQC. Both of them we are dividing with the area of APQ. See students, APQ, APQ. So both of them we are dividing with the area APQ, area of triangle APQ. So we have divided with the same thing, hence equality will not be disturbed. They are still same. Now actually we need this. For that we have to reciprocate them. We are not going to reciprocate them. So hence it will be reciprocated. Area of APQ over area of BPQ will be equal to area of APQ over area of PQC, right? Now you see students, this implies this area upon APQ over BPQ is AP upon BP. So in place of this we can write on, let us write here only, this can be replaced by this. So AP upon BP is equal to, and this is the same thing here, APQ upon PQC, APQ upon PQC, so this is equal to AQ upon QC. And this was what we required. AP upon PB is equal to AQ upon QC. AP upon BP is equal to AQ upon QC. So we shall write in the end, hence proved. Thank you so much students. Write it 5 times, 6 times until you are learned with it. Thank you.